Hello everyone, I'm glad to see you back on my channel. So again, we continue to solve different exercises to prepare ourselves for practical parts on the technical interview and especially for fun companies, for example, like Google. So let's prepare together and maybe in a few months, maybe years, depends, we will reach our goals and uh, we will become good in that type of interviews. So today we will overview an exercise which is called max area of island, and actually it's pretty similar with a problem which we have already solved. It was called probably number of islands, so it's pretty similar. So I advise you to watch this video, which is already published on my channel. But if you have already watched the video, I think this one will be pretty easy to understand for you. So okay, let's proceed. Let me try to explain you what is the idea of a task and what algorithm we can use here to solve it. So the idea is that we have here a grid, which is actually a matrix, and every cell can have only one value. So it can be 0, which means that this is water, or it can be 1, which means that this is island. And everything what is outside of these boundaries. So for example, this one has coordinates 0 0. For example, if we would have -1 0, then it also considered like a water. So also a small note here. And you can see that here we have a lot of islands. So we have island with area 1, we have island with area 1, 2, 3, 4, we have island with area 1, 2, 3, 4, 5, and so on. And our task is to find the maximum area. So the answer here would be 6. And also here, one important note is that probably you may ask me, so okay, Alex, but why maximum area is 6, 1, 2, 3, 4, 5, 6, but not 7, 8, 9, 10, 11? Why this part is also not considered like a part of this island? So here we have a condition that only cells which are placed on the left side, right side, on the top or on the bottom can be considered like part of island. So for example, if we would have here 1 instead of 0, also it would be considered a separate island, but not part of this island. Okay, and what algorithm do we need to use? So we will go through all cells inside our grid, and we will check if this cell is equal to 1. If it's equal to 1, it means that we have reached the island. And now we need to find out the area of this island. And how we can do that? So we just need to understand how much cells are part of this island. So for example, here is 1, 2, 3, 4, yeah? So we need to find out how much cells, and then to create, for example, a variable, let's say we will call it max area, and we will compare. If current max area is greater than max area which we have found previously, it means that we need to change it. If not, we leave what we have found in previous iterations. And also, one important thing here is that, for example, when we will, let's say, reach this cell, we will recursively check his neighbors if they are equal to null, so or equal to 1. So for example, if I reach this one, I need to validate it. So I check if this cell is equal to 1. Yes, it is. So it means that now I want to check if his neighbors also are equal to 1. And neighbors are considered cells from the top, from the bottom, from the left, and from the right. And now let's say that we check his neighbor from the right. And again, we can see that his neighbor value is equal to null. And now we again need to check his neighbor. So the cell from the top, bottom, left, and right. And here, one important thing is that all cells which we have already visited, we need somehow to mark them like visited, because if we would not do this, when we will make the same validation for the neighbor, we will go back again to the visited cells, and it will cause infinite loop, which we want to escape. Yeah, we don't want to do this, so we need to mark them like visited, all visited cells. So that's the overview, and I hope the algorithm is clear. If not, please write in the comments, I will try to help you. And now let's try to see the implementation of this algorithm. So let's go to our IntelliJ IDEA, and here I've already prepared a signature, so we will have a method max area of island, and here is our grid with different values. Now, first thing which I want to do is to check if this grid is not null. So if it's null, or if his length is equal to 0, that means that I don't have any elements, so I need to return null, like max area. So let's put here this condition. Let's check if grid is equal to null, or if grid length is equal to 0, it means that I want to return 0. Perfect. All right, now let's create some variables, because I want to store how much rows do I have in this grid and how much calls per row I have. So let's create two variables, rows. Here we will store the rows, and now let's create a variable for calls, grid, and here length. Perfect. Now let's create a separate variable which we will call max area, where we will store our max area. Initially it will be equal to 0. Okay, now I want to traverse my grid. For that I will need two flares. One will be inner flare, because if you remember, when we talk about matrix, the coordinate of one cell is index of the row and index of the call. So let's do that. Let's create a force. Here we will have row. We will iterate until row is less than maximum rows, which we have in our grid, and row plus plus. And same we need to do for calls. And calls plus plus. Okay, perfect. Nice. So now the next step which I want to do, I want to check if the current cell is equal to 1, because if it's equal to 1, I need to update the maximum area, and also I need to call recursively DFS method. DFS method will be a method which will recursively call for all neighbors and will validate them, kind of. So let's do this. Let's check if the current element, so grid, if current element is equal to 1, then in that case let's call let's first create the signature for that DFS method. Try that int DFS. Here, like argument, we will send our grid and the coordinates of the current element. Okay, and here we'll call this test method. Here we will send our grid and current coordinates. Perfect. And now this test method will return the area of one island. So imagine that we start from this and now we call recursively our DFS method, which will increase our current area when he will find a cell with value 1. So we'll have first 1, then 1 from this neighbor, 1 from this neighbor, 1 from this neighbor for this cell, and in the end they will have 4. And let's store this value, so let's call it current area. And now let's imagine that that we already have processed this island with area 1 and this island with area 4. Now we have processed this island, so we need to compare his area with areas which we have already found and stored in maximum area, and if it's greater we will change it, if not we will not change it. So let's do this. Max area is equal to max. So we need to compare max value between previous max area and current area, and the greater value will be stored in this variable, and in the end we will need to return this, return max area. Perfect. So it's almost done, but now we need to implement our fast percussion traversal, and here again let's create 2 variables. In these variables we will store how much columns and rows we have inside our grid. So rows is equal to grid dot length, and calls is equal to grid dot length. Okay, perfect. Now, because we will call this method recursively, we first think about which we need to think is when we want to stop this recursion, because if we will not stop the recursion, it will be executed infinitive time, and we don't want this. So when we will stop? We will stop in case if we are out of bounds of our grid, or in case if the current cell is a water. So if it's a water, we don't need to process it, and we just need to return back. So let's put these conditions. So first condition will be if we are out of bound. So if row is less than 0, or if row is greater or equal to rows, or for columns now we need to do exactly the same. Okay, just need to put here columns, and here columns, and here columns. Calls. All right, and in the case if current cell is water, so if it's equal to 0. Perfect. And in that case we will return 0. Okay, perfect. And now when we have traversed our current element, so we need to mark it somehow like traversed. So for that we just take our current element, row and call, and let's mark it like visited by doing so. So we will, just instead of 1 it will be 0. Okay, and now let's create variable int area, which is equal to 1. Why 1? Because we have already processed first cell with value 1. Yeah, and now we want to call our DFS method, so recursively, for neighbors of the current element. So the first current element will be the starting point of the graph, the starting point of the grid, let's say. So the first island. So now we want, when we will reach the first island, now we want to call this method recursively, because we want to check and want to calculate the area for this island. So let's do this. Let's call this method recursively, the fs, but for our neighbors. So grid r minus 1 and column. This will be for neighbor from the top. Now you want to do this for a neighbor from the bottom. Now for neighbor from the left. And neighbor from the right. And now these methods will return the area for each cell, and we need to take this area and to add in this one, in this area. Yeah, so we take our area and just add the area of the neighbor. So for example, when we will reach the first cell, it will have area 1. Then we will call the fs for his neighbor. From the left there, let's imagine that we have only one cell with value 1. It will return to us value 1, and we will add this one to this one. So we will have already 2. And this thing we will need to do for all neighbors. Let me just copy this. Area. And here area. Okay, and in the end, when we will go through all our neighbors, we will need to return the final result, area. And then it will return the final result in this variable current area, and we will compare it with the max area, which we already have found in previous iterations, if we have this value. So that's the main idea how we can write a solution for this task. And now let's proceed and check the complexity for this algorithm. So let's go here. So the time complexity for this algorithm will be OMN, and the space complexity also will be OMN. So that's it. I hope everything is clear, and we will see in the next video. Bye.